Many people also do not do trigonometry. This is just the last minute thingy for the area. Okay, area is equals to a half AB sine of C. Okay, to teach this is this area sine of C. Okay, this angle, this is side length A, this is side length B. Why does this work? This is the base. The sine C comes from this length is a sine of C, meaning A sine C, and this is A sine C. So that's that. For the sine rule, it is A or sine of A is equals to B or sine of B. How does this work? This is only if you have this condition A, B, you have this angle and you have this angle. This angle B corresponds to this angle A corresponds to this. Okay, this is only for when you either have one length missing or one angle missing. Okay, this is used to find the angle, A angle or A length. Okay, here you need to know two angles and a length, or two lengths and an angle, at least in this structure. It is used in a triangle. Okay, and I hope that's that. And for the third one, wait, which is cosine rule, it is c squared is equal to a squared plus b squared minus 2ab cosine c. This ABC can be interchanged. Basically, how it is triangle, this angle CAB. AB are the legs that make this angle, and the angle is opposite to the side. Okay, that it finds, that this formula finds. You can solve for the angle itself, which is cosine of C is equals to a squared plus b squared minus c squared all over 2ab. Very easy. Okay, these two are the formulas you need to find. This cosine of c is helps finding the angle itself if you have all three sides. This formula helps to find the side length opposite to this angle if we have the angle itself, the length, the measure of the angle, and the um, length of the sides that make up this. Okay, this is the formulas that people needed to know, and I hope people make use of it. Lastly, you need to know your ratios. SOHCAHTOA, which is SOHCAHTOA. Sine is equals to opposite over hypotenuse. Cosine is equals to adjacent over hypotenuse. Tan is equals to opposite over adjacent. Nice, nice, nice. You need to remember this because in a triangle, it is hypotenuse opposite adjacent of this angle. The sides respective to this angle is opposite, adjacent, and hypotenuse. In a 90-degree right triangle. Okay, this is important and this is needed for your thingy. If you are IGCSE, you need to learn your trig values like I told you earlier. For O levels, this is all you need for it. Okay, and one last thing. I'm running out of ink. Someone please donate me some ink. One last thing is sine. Oh god. I thought this would fill up faster. Sine of O is equal to sine of A. Cosine of O is equals to negative sine of A. Tan of O is equal to negative tan of A. What is this OA thingy? In a this Okay, this angle, the sine of this acute angle is the same as the sine of this obtuse angle. Okay, sine of this obtuse angle. Remember, sine is sine. Okay, for the cosine, it is opposite. Okay, it is negative. Okay, the negative of the acute angle is the same as the cosine of the obtuse angle. Oh my god. Sorry. Okay, so the sine stays. Why? Because if we see, the height is the same. The height is the same. So the for the obtuse it remains the same. For obtuse, for cosine it is negative. Why? Because it is like backwards, kind of. Think of it as like backwards. Okay, it's like in a negative. Negative means backwards, reverse. So you can think of that as that cosine. The negative cosine of acute is the same as the cosine of obtuse. Obtuse and acute have the relation 180 minus 180 minus acute is equal to obtuse. Remember this relation, or acute plus obtuse is equal to 180. And the same is tangent of obtuse is equal to negative tangent of acute. Only sine is positive, the cosine and tangent is negative. Okay, you need to learn this will likely come in useful for bearings.